Okay, and so I'm gonna get started here. So if you guys will hop on Discord and take a look at the screen share, we're gonna talk a lot about loops this morning, and you know, try and make this a functional lecture. And what I mean by that is kind of include a lot of the material that you'll need to complete your labs. And so, focusing this morning, will better prepare you for your labs. So by focusing, that does not include looking at your cell phone or Facebook or whatever else. So please put those devices away and let's focus in. And so I'm going to start by creating just a console app and C sharp, and I will create this in someone's repository that I can then later delete. So location's not super important. I'll put it in the lab folder here. Just happens to be Alexis at the top. And if I look at this is chapter 05. So the solution name chapter 05. And this will be project name loops. Okay, so we're back at the console and the GUI maybe as well. When it comes to loops, okay, we spent a week or so talking about control structures, specifically if-else's and switches, really. And one big takeaway that as long as I've been doing programming, I at a very high level look at these control structures and I say these control structures make our program smart, right? If you go back to the lecture where we got introduced to these statements, I said, hey, learning these statements will make our software smart. I said, hey, like we got smartphones. These smartphones are smart because they can make decisions based on conditions. And that's exactly what happens inside of your if-else statements. Your if-else statements are allowing your software to make decisions based on certain inputs. Okay? So making your software smart. Okay, the creation of the smartphone was possible because of things like the if statement. Without the if statement, no smartphones. Okay, no smart fridges, no smart cars. Well, another control structure that we have not yet covered are these things called loops. If statements make our programs smart, loops makes our programs powerful. And the idea behind why I say it makes the software powerful is because loops enable us. I mean, if you might guess what a loop might do, is it might execute a line of code over and over and over repetitively. And so with a loop, you can execute lines of code repetitively. Good luck on spelling that one. Repetitively. Okay, repetitively. So a few lines of code can do a whole lot. That's the idea of making your software powerful. I think of one search query on Google or one search query on Amazon or one search query on Spotify. And that one search query returns a lot of results, pages and pages of results. The idea is that, hey, I can get one result at a time and then format that result on a page repetitively, right?
So
Yes.
Google is just a big loop.
What's that?
Google is just like a code that's
Well, it certainly utilizes loops. Again, the idea is that, hey, I'm going to get 1,000 songs back if I search for an artist and they've got 1,000 songs, right? And now I'm going to format each song on the page one at a time using a loop over and over and over again. Put it on the page, and repeat and repeat and repeat and repeat. And so, as fundamental as if statements are to making our program smart, loops allow us to execute lines repetitively, and so we can write a little bit of code and get a lot out of it. Make sense? Write a little bit of code and get a lot out of it. Now, when it comes to loops, there are a few kinds of loops, and I'm going to stay focused on one kind that is, in my estimation, you're going to see this the most. But let's just go through the different loops. There's a loop called the while loop. There's one called a do while loop. And there's one called the for loop. And so these are the three loops that we're going to cover today. We're going to spend most of our time focused on the for loop because the for loop is, again, in my estimation, the one that you'll use the most. And so I want to kind of focus on it. Now, just kind of off of the top, we got a visitor here. I'm going to pause. Okay, so I want to go through these different loops. And again, I want to stay focused on the for loop because we'll use that the most. And then again, I want to kind of solve this for some of the things you'll need in your lab. If you guys remember, we talked about code snippets a little bit. Code snippets, if you right click and where's the hotkey for code snippet? Let's see, insert snippet, there, the word snippet, and then insert snippet. If you start typing, there's another way of doing this, but this is just one way off of a right click, insert snippet. And then you click on C#, and then you can type in, for example, a while loop, and it brings in the basic structure of a while loop. Okay, now that's kind of the long way about it. The shorthand, if you type the word while and then you hit tab twice, that's the way to insert a snippet quickly. Okay, so I can, if I start typing a do while, I can hit do tab tab, and then I can type in for tab tab. For tab tab and get the structure for each one of these loops. Now, the for loop, from my memory, actually had a little bit more that came along with it. Oh, there it is. Okay, I don't know why this is what I expected for the for loop. So again, if I hit for tab tab, why is that doing that sometimes? Let me go up here. For tab tab. Okay. You guys should get this when you type in a for loop. I'm not sure why sometimes it's doing that for me, sometimes it's not. So that's kind of the first thing, that as you're learning the syntax of these different loops, the code snippets will help you, because notice it's got the semicolons where they belong. It's got these little Boolean true statements that inside of these parentheses go conditions, just like in your if statements, that will determine how many times this loop executes. So some terminology. When I say an iteration of a loop, an iteration of a loop means a single trip through the loop. And so if I say a loop iterates 5 times, that means you go through the loop 5 times, right? And so right now, what determines how many times this loop will execute? How many times does it repeat, in other words? Okay, that's when you hear me say an iteration of a loop, how many times does that loop repeat? That's what I'm talking about. And so to answer that question, how many times does a loop iterate? How many times does it repeat? You need to declare what is often referred to as an iterator variable. Okay, the iterator variable will go through the loop and it will be part of determining how many iterations occur. It'll be a part of the equation. So in all three of these loops, there's this thing called an iterator variable. You'll notice down here they declare this variable called I. The reason why it's so commonly called I is that it's short for iterator. Okay, it's going to help determine how many round trips through the loop that occur. Okay, so these are the three parts. There's an iterator variable. Then you need to test the iterator variable for a Boolean condition. What's a Boolean condition? Remind me from our if statements. A Boolean condition evaluates to true or false. So we're going to have this iterator variable, and then we're going to test it for truth or false. If the test is true, the loop will iterate. If the test is false, the loop will not iterate. So there's what's called an iterator variable. There's a test of the iterator variable. So we'll call this declare the iterator variable. This is part 1. Testing the iterator variable is part 2. And then modify the iterator variable is part 3. And I'll explain why we need to modify the iterator variable here. So let's do this. I'm going to just focus on the while loop off the top. Let's declare an iterator variable. Int I equals 0. It is, conventionally, our iterator variable, in this case is I, starts at the value of 0. Okay, it's convention. It's not always the case, but it is convention. While I is less than 10, console write line, the value of I is I plus plus. Okay, let's look at this. On line 24, we declare a variable. That variable identifier is just called I. I represents the word iterator. On line 26, we have this keyword while and then some parentheses. It says while I is less than 10. Is 0 less than 10? That's a question. It evaluates to true or false. Well, of course, 0 is in fact less than 10, so that is true. Therefore, because this is true, we go into the body of the loop. Notice what I have highlighted currently. That is referred to as the body of the loop. It is in between curly braces. Okay, so lines 27 through 30 is referred to as the body of the loop. And what the body of the loop does is it prints out the value of I as 0, and then it increments I to 1. So question for the class, how many iterations will this while loop have? 10, right? If you're paying attention, you can add those up. I is the iterator value, will iterate from 0 through 9. Because 9 is less than 10, obviously. When it prints out the value of I is 9, I will go to 10. Is 10 less than 10? No, therefore we're finished with the loop. And just to demonstrate that, I'll say the loop is finished. Okay? And so up here, I'll say console.writeLine, the loop is about to begin. Okay? And so here's our output. We wrote one loop, and you could see it got to execute that body of the loop 10 times. As we determined, it iterated 10 times, while I is every value from 0 all the way up through 9. Okay? I break down this loop because these 3 different parts are in all 3 of our loops. The while loops that we just talked about, right? You've got while, you've got these parentheses. These parentheses, I mean, let's be honest, it looks just like an if statement, but instead of the word if, you've got the word while. Now, don't get the two confused. If statements run code conditionally based on a condition. Loops run code repetitively. Okay, so the question is, do you need to run something conditionally, or do you need to run something repetitively? If you need something conditionally, you need something like an if statement. If you need to do something repetitively, you need a loop. Okay. However, syntax-wise, if I code an if statement, okay, notice that this if statement looks just like this while loop. The only difference is the keyword. Okay, but they just, obviously, they do different things. Okay. I'm just pointing it out. It's similar. It's similar in syntax. We've got 3 parts. What are the 3 parts? You can read them to me. What is part 1? Declare an iterator variable. Part 2, test the iterator variable. And part 3, modify. Let's see what happens when you forget to modify. Check out line 31. I just commented it out. Okay? Well, what happens here? Is 0 less than 10? Yes. Is 0 still less than 10? Yes. Is 0 still less than 10? Yes. Is 0 still less than 10? Yes. Okay, this is the famous infinite loop. Okay? What we have here is a program that never ends. When I was a kid, I grew up with lamb chops, and there was a song that never ends. This is the loop that never ends. You guys remember lamb chops? A couple people rolling their eyes in the back of their head. This is the loop that never ends. If you write software that does this, this is how you get program not responding up at the top, and your software will crash, right? So if your software hits an infinite loop, okay, like this is a problem, and your computer will eventually run out of RAM. It's going to consume all of your computer's resources and ultimately crash. So part 3, this modification of the control variable, of the iterator variable. You might hear me call it the control variable, but it's better called the iterator variable. If you leave that out, you create an infinite loop. I'll leave this. If you forget to modify the iterator variable, you'll wind up with an infinite loop. Trying to play in the title Infinity War Avengers, but no, there's no tie-in. A war that never ends, a loop that never ends. Okay, moving on. There is also something that's a similar term that is a book term called an indefinite loop, right? An infinite loop, indefinite. An indefinite loop goes on for an unknown amount of time. Okay, I'm going to show you how to code an indefinite loop. When we get into for loop. 1 second here. Okay. So another piece of theory that's really important about a while loop. What happens if I do this? What happens if I say I is 100? Will that loop iterate ever? No. 100 is not less than 10. So this while loop is known as a pre-test loop, meaning the conditional test happens before the body of the loop. It's a pre-test. If the test is false, the body of the loop will never run. Going on to the next line, I'll say pre-test loops will iterate 0 to many times. 0 to many. There's really no upper bounds as far as how many times many can be. Many can be 1, many can be 100, many could be 1,000, 10,000. There's no upper bounds. Okay, but it will iterate 0 to many times. Right.
So my question is, so like, whatever, I greater than 10, if
I less than 10, yes.
I less than 10, if you put that at 100 or something, would you be able to infinitely loop that? Or
If I put I less than 100,
yeah, would that be able to loop to like where it goes on 101, 102, 103 like that?
so keep in mind right now my I is 100. Do you want my I to start at 100? Is that what you're saying?
Yeah, basically.
So right now I is 100. Is 100 less than 100? That is false. So this will never execute. Do you want it? You kind of mentioned getting it to go from 100 to like maybe 110. So if I'm guessing it, maybe kind of where you were going with that. If I start I off at 100 and I say while I is less than 110, I print out I and then I increment it. If I run that, I can get it to count from 100 to 109. Okay, if I want to include 110, right, I could say less than or equal to 110. All of those comparison operators that we learned about, those still exist, right? So now you're going to notice it included the 110 in the body of the loop. And so this loop iterates 11 times. Okay? Is that kind of where you're going with that?
Yeah.
Yeah.
Would it crash the program if you start at 0?
Would it crash the program if you start at 0? No, it's just going to take a little bit longer to run. Now that it happened so fast you couldn't even see it. But that literally counted from 0 to 110. Right? What if I said while I is less than a bigger number? Well, again, it happened so fast I couldn't keep up, but it counted all the way up. I just made a loop that ran a body of a loop 1,101 times. Right? But our computers are so fast. Like maybe if now again, there is an upper bounds. I mean, you could throw in a loop here. There it goes. These things fly pretty fast. You can throw in a number that's too big. You can break it. Apparently that's not big enough. That's not the point of this lecture.
Let's just keep it going.
Yep.
This is finally, this is my favorite part. Okay.
That's too much.
So let's take a look at the next loop, and then we'll get into the most important, the for loop. And so the other one we said was a do while. So I'll start with the keyword do, and I'll hit tab. I'm going to give you the 3 parts again. Int I is equal to 0. Do console write line. The value of I is, put my little $sign up front. Put my curlies right here. I here. I plus plus again, plus I plus plus makes no difference. While, and I'm going to replace the word true, while I is less than 100. Okay, this is going to count from 0 to 99. This loop will iterate 100 times. And it happens so fast, I Don't get to drag the window over. Okay. So there's no major difference besides one. There's one significant difference between a while loop and a do while loop. Look, at the end of the day, they both just took a block of code, the body of the loop, in this case between 27 and 30, and it executed that body of the loop many times. If I wanted to do something else, like you can put a bunch of things. The value of I plus, I minus 100 is I, and I can literally go minus 100. And the value of I times 2 is, and so every time through the loop, I'm going to print out 3 things. And I'll just decrement this down to maybe 5 iterations. The value of I is 0. 0 minus 100 is negative 100. 0 times 2 is 0. The value of I is 1. 1 minus 100 is negative 99. I times 2, 1 times 2 is 2. So on and so forth. Right? The point is, the body of the loop is being repeated. This loop iterates 5 times. So it does these 3 statements 5 times. So the body of the loop is what's repeating here. Right? So in my Amazon example, you get 1,000 results, you print out 1 result in the body of the loop, and then you repeat that. The one difference that I was getting at, look what happens if I do this. If I say I is 100, let's just make it 1,000. You're going to notice that a do will execute the body of the loop before the while is ever tested. So a do while is different than a while loop. A do while loop is different from a while loop in that it is a post-test loop. Meaning it will iterate at least once, 1 to many times. Remember, the post-test loop, or the pre-test loop, I should say, the while loop is a pre-test loop, and that will iterate 0 to many times. Right? This iterates 1 to many times. So it doesn't matter that I is 1,000 and 1,000 is greater than 5. It's still going to iterate that body at least once, as demonstrated. 1,000, 1,000 minus 100, 1,000 times 2 is 2,000. And so that's the big difference behind a while and a do while. Otherwise, they're the same. They got the 3 parts, the iterator, the test, and the modification of the iterator. All right. Now, what we're going to do is I'm going to send everyone on a break, and when we come back from break, we're going to talk about the for loop and talk about how that fits in. All right. Okay, we're going to continue in our discussion of the loops, talking about the 3rd loop in the list, which is a for loop. I'm going to hit for tab and fill in this snippet. What's nice about this snippet is it does all 3 of these things in one place. And so one downfall of a while and do while, one downfall is that the 3 parts can happen anywhere in a program. And so you might declare an iterator on, line 5, you might test it on line 300, and you might modify it on line 1000. And so to kind of like follow the flow of a while loop, it can be a challenge to to understand all the different parts when they're spread out throughout the source code. They're not all in one place, right? And so the benefit, one of the major benefits of a for loop is that all three parts are on one line of code. You can see we're declaring and initializing a control variable. We're testing that against something. Now in this case, this is something we need to fill in. We need to finish this because we don't know what we're testing. And we're modifying the control variable all on line 24. And so the benefit of a for loop is that all three parts are in one line of code, and it's nice and easy to understand just by looking at it. If I say I less than 10, like I've got all the pieces, okay, how many iterations is that? You can look at that and say that's 10 iterations. And you could tell by looking in one line of code where it's all at. Again, these other loops, that's not always the case, that it's easy to kind of trace and understand those loops. Question?
Are you like basically just like merging it? Like
Putting it all in one place. Yeah. And so I can kind of console write line. And you're going to see this is just going to work just like the other loops. Now, the way this happens, okay, and there's a flow of execution to the for loop. Step one of a for loop is to declare and initialize the iterator variable. Step two, test the iterator variable. Step three is actually to run the body of the loop. If the test is true, then run the body of the loop. And then step four is to modify the control variable. I keep calling it the control, the iterator variable. And step five is to then continue and test the iterator variable again. Now, I will just say that when I was learning the for loop for the first time, I didn't expect that to be the flow. Okay? So these steps happen in this order, and you need to understand those steps, you know, the flow of those steps in order to understand a for loop. Okay? It's because of those steps you're going to notice the test runs before the body. What do we call those when the test runs before the body? Pretest loop. We call the for loop. The for loop is a pretest loop. Like which other loop that we learned about? Like the while loop. For loops are also traditionally known as count-controlled loops. What that typically means, to call it count-controlled, is that I could just look at it and I can count the number of iterations. Typically, you can look at a for loop and you can just count, okay, that's going to iterate 10 times. Okay, this is going to iterate 100 times, so on and so forth. Okay, that's what it means to be count-controlled. The opposite of count-controlled is an indefinite loop. An indefinite loop means you have no idea how many iterations will execute. Okay, and we'll give an example now of an indefinite loop. Okay, however, I'm not going to use a for loop because, again, traditionally, you know, the thing that makes the most sense now is to say, okay, when do you use each loop? Now that I've kind of learned that there's three loops, all three loops have the same three parts, when do I use each loop? Well, a while loop A for loop is count controlled. Okay? Most of the time, but not always. So if you need to do something some number of times, for loop is good for that. You can just look at it and count the number of iterations. In the real world, if something needs to happen 0 or many times, you could use a for loop. Okay? Regardless of whether you can count or not. I mean, really, it really boils down to this. In the real world, does your program need this thing to happen 0 or many times? If so, then you can use a for loop. Same exact thing with a while loop. A while loop is 0 or many times. Now, I will also say, traditionally, like it's good, a while loop, if you have an indefinite loop, you might consider a while loop versus a count controlled. Okay, for loops are better count controlled. A while loop is more of an indefinite. Okay, however, those are just suggestions. Those aren't really hard requirements. It's just more traditionally a for loop is count controlled. A while loop we could call indefinite. And then a while loop, well, it's just one or many times. So I got asked a question on break. It's like, hey, will you cover when to use each? Well, the answer to that is, well, do you need the body of the loop to execute 0 or many times? If it is, then do you know how many? Is it count controlled? Then you might use a for. If it's indefinite, you might use a while. However, either one could do the trick if it's 0 or many. And then if it's one or many times, well, then that's your do while loop. Okay. Now let's give an example of something I haven't done, which is an indefinite loop. And because it's an indefinite loop, I'm going to go back to a while loop. I could actually make this for loop because I said you could make a for loop indefinite, but for right now I'm just going to stick with the while loop being indefinite. Please enter a number or the capital letter Z to stop. Actually, I'm going to say 999. Please enter a number to sum or 999 to stop. So 999 is a special value that is called a sentinel value. Sentinel value just meaning you're going to stop when the user types 999. So the idea behind sentinel values is you want it to be a value that the user's not likely to type otherwise. Right? Probably the user's not going to type 999. And so 999 is a pretty good sentinel value in my case. Okay, but if 999 is a valid input, it might not be a good sentinel value. You get to make up what the sentinel value is. I'm going to say int user input equals convert 2 and 32 console read line. While user input is not equal to 999. So I've just made a loop using a while loop that's going to loop an unknown amount of times. It's going to loop until the user types 999. As soon as the user types 999, well, then we're done here. And notice if they type 999 at the beginning, this loop will never iterate. At the end of this, I'll say, thanks for using my program. So just to demonstrate, if the user types 999 to start, it skips the loop altogether. Okay? User input is equal to 999. So this becomes true and it goes into here. And so I'm going to change this language. I'll say, please enter numbers to sum. Right? So I'm going to ask the user for many numbers. Now let's make the sum. Int sum. Okay. Now sum is going to increase. Sum is a variable that's going to get bigger every time through the loop. When a value gets bigger, or every time through a loop, it is called an accumulator. Kind of makes sense. You're accumulating value. You're every time through the loop. So you got these new terms. One's called a sentinel value. One's called an accumulator. Accumulators should be initialized with the value of 0. Okay, and there's some reasoning behind that. You could take it for just a rule, like you're going to notice right now, like just leaving that off. It's probably going to say, hey, it's never used. That's fine. I'm going to start it off at 0. And then what I'm going to do is I'm going to say sum equals sum plus user input. So if they did in fact enter 999, the body will never execute. But if they don't enter 999, any other input, we're just going to say, okay, the new value of sum is equal to 0. The first time through the loop, sum is 0 plus the user input. Okay, now remember there's 3 parts to a loop. The first part is your iterator. Now I called this user input. Before I called it I, but notice what we're testing is user input. So our iterator variable in this case is called user input. I didn't call it I called it user input. So I declared this iterator variable, user input. I test it on line 32. So part 1 is on line 26. Part 2 is on line 32. But of course, what I've left out is part 3. What was part 3? Part 3 was modify the iterator variable. Modify the iterator variable. So inside of your loop, what happens if you don't modify your iterator variable? What do we call that? It becomes an infinite loop, right? So don't forget to modify your control variable. Of course, now we need to ask the user again. Literally, you can copy this line of code, these 2 lines, and paste it. And instead of redeclaring it, you just assign it. Okay, now all I did, okay, on this copy and paste is I removed the keyword int. I didn't need to redeclare. Cell phones. I didn't need to redeclare my iterator variable. So let's see how this works. Again, this is going to help you out with your lab. So if I say 1, 2, and 3, 999 to stop, thanks for using my program. Of course, what I should also do is display the sum. Console.writeLine, the sum of the numbers is this is known as an indefinite loop. And based on user input, we have this sentinel value of 999. And we also have this accumulator value that's getting bigger every time through the loop. And these are pretty normal things to do with loops. Now, let's say that what I'm summing here are test scores, which have a valid range of values. Like right now, obviously, if I were to say, oh, my test, I got a 200%. That's a valid, right now, that would accept that. I say 200 and 200, I got two tests, the sum is 400. But let's just say that these numbers represent test scores. And let's just say that our test score values are only valid between 1 and 100. How might I go? So what I don't want to do is increase the sum if it's a bad score. So how might I go about doing that? Any thoughts? Yes. Yeah, let's go with an if statement. That is the correct answer. So what might that if statement look like? If user input yeah, input. Did I call it input? Oh my goodness. Oh, come on. Let's call it input.
I thought you were doing it as
Not intentional. No. Why? Okay, back to our if statement. If user input
is greater than or equal to 0, and then set up and
if user input is greater than or equal to 0 and let's type it right. And
user input is less than or equal to 100.
okay, so this would be considered valid score, yeah? This
Do we need both ampersands, or will just one work?
you want to use both. One would work, and two is more efficient.
Two is more.
So you just do the two.
So they're interchangeable, really.
So if it's a valid, I would just use the two.
Got
You never see the one, okay?
All right.
So in the case that it's a valid score, then we're going to increase the sum and prompt for another one. Else, we're going to say invalid score. So in the case of an invalid score, I'm just going to say console right line. Valid scores are between 0 and 100. Please enter a test score. So I'm going to give the user more information up front. Please enter a test score 0 through 100 to sum or 999 to stop. And then I will reflect this language in the successful use case. Since now we're only accepted valid input, we want to tell the user what the valid input is. And I'll say input not accepted. Valid scores are between 0 and 100. So you can see how now we have powerful programs and smart programs. We start merging these tools together, loops and conditionals. And we can start doing some pretty useful stuff. And so now please enter a test score. If I say 101, okay, what's going on? I've got an infinite loop. Let's take out the prompt. Let's take the prompt out of the valid score. So in the case of valid, we increase the sum. In the case of invalid, we say not accepted. But then regardless of a valid or invalid score, we ask the user for another number. Notice how now I've taken this right here is what we call the modification of the iterator. Yes, sir.
So noticing that we have the first one, like the first console right line and something before the while loop, is it possible to start a while loop while just leave like end user input semicolon and then doing the while loop, or do we need a console read line and a console write line
Well,
before the loop?
the reason here is that the while loop is a pre-test loop, so you needed something to test against.
Okay,
So in this case, you did have to initialize it.
so we need like a control
Yeah.
first.
Yeah.
Okay.
Okay, so now if I run that, and we go back and we just enter an invalid score of 200, input not accepted, valid scores between 0 and 100. If I say 100, and I say 90, and I say 80, and I say 999, well, 1 plus 90 plus 80 is 190 plus 80 is 270, so my sum is working. Then it says, thanks for using my program. It rejected the invalid score and accepted the valid test scores. So if you're looking at this and go, boy, this is speeding up, the answer is yes, it is speeding up. You're going to have to take what you've already learned with these if statements and figure out how to meld them into these new things called loops. All right, now I'm gonna stop the lecture right here, and we will continue in lecture tomorrow. But we'll have a couple hours today to work on labs.